this op-amp problem. Here we have an op-amp and we don't know the output voltage. Let's see how we can find it, and also we can find all the currents in this circuit. Let's see how we can go about it, how we can do this. First, we have to see whether we can find voltage in any terminal. And when you are dealing with an ideal op-amp, you have to know that current going in or current going out of the input terminal is always 0. So it's 0 here, and yeah. Okay, so this is 0, this is 0. So the whatever the current going here should be the current going right here, right? So from this one we can solve for the V plus. V plus is going to be I times R according to Ohm's law. So this is 1 milliampere times 10k. K and milli cancels each other, so we are going to get 10 voltage right here. Okay, so if V plus is 10k, the according in ideal op amp, if we have positive terminal voltage is 10 voltage, the negative terminal also going to be the same. So V minus also 10 voltage right here. So this one is 10 voltage, this one is 10 voltage. So from this one we can apply KCL at this node and find out some unknown variables. Let's apply KCL for this one. So let's call this one current IX. Let's call this current IY. And if the current going to the input terminal is 0, then IX must be equal to IY, because there's no other way the current passing through this node. So IX is going to be equal to IY. Ix is going to be equal to Iy, and from this one, you know, Ix is straightforward. We can actually find out without adding any equation by just looking at the voltage difference divided by the resistance. So Ix is going to be equal to 9 minus 10 divided by 100. 9 minus 10 divided by 100. So that is negative 1 divided by 100, and that's going to be 0.1, negative 0.1 milliampere. So the current direction is basically the opposite direction. Okay, and this is going to be equal as well. If Ix is this one, Iy is going to be equal because Ix is equal to Iy, and that's also going to be opposite direction. Negative 0. Okay, 1 second. Yeah, negative 0.1. Let me double check. 9 minus 10 divided by 100. Minus 1 divided by 100. That is 0.01 actually. 0.01 ampere. That's equal to 10 milliampere. Negative 10 milliampere. Negative 10 milliampere. So this one is also going to be negative 10 milliampere right here. Okay, now we found out V plus, V minus, Ix, Iy. What about this current? Let's call this one IZ. What is IZ? This is going to be 0 because this is an open circuit. So IC is 0. What about this one? We don't know. But let's call this one IO, open op-amp circuit. So I call this one IO. Let's name this one as IW. Now we know the do we know the voltage here? We can find it out by applying, like, we know the Iy is going from here to here, so we can also combine these two resistors and make it 1700 because you see these two are in series, so we can add them together So this is going to be 1700 total ohm resistor. So this is going to be the IY equation is going to be 10 minus this voltage right here. Okay, let's find out this voltage first. And if you find this voltage, this is going to be the same voltage right here, because there's no voltage drop, because there's no current going through this. So this is also going to be V1. So 10 minus V1 divided by the resistance in between, that is 1700. Okay, and this one is 10 milliampere. Now we can plug the value for IY. Let me do it a little below. So 10 milliampere is equal to 10 minus V1 divided by 1700. If I bring this 1700 this side, this is going to be 17,000 milliamp, and that is equal to 10 minus V1, and 1000 and milli cancels each other, so we get rid of it. And if I bring V1 to this side, V1 is going to be 10 minus 70, that is minus 7 voltage. Let me double check. Oh, and also this is minus 10 milliampere, so this minus 17. So that's going to be plus 17 right here. So that's 27 volts. 27 voltage. Okay, and now we know the voltage here, and we can find out the IW, because we know this voltage, right? This voltage is the one we found out before. That is this 10 voltage. V1 minus 10 divided by resistance between. Let me use a different color here. IW is equal to V1 minus 10 divided by the resistance between. V1 we just found it out that to be 27. So 27 minus 10 divided by 250, and then 70 divided by 250, and if I multiply this one for 4, that is 68 divided by 100. Seventeen divided by 250. Oh, this is actually ground, connected to the ground, right? This one is 0 voltage. 0. So this is V1 minus 0 divided by 2. 27 minus 0. 27 divided by 250. 27 times 450, 108. 108 divided by 1000, so 108 milliampere. Okay, now we have this current, this current, this current, this current, this current. We can apply. We still have to find out the IO. If we can apply KCL at this node, we can solve for IO as well. Okay, according to Kirchhoff's current law, summation of current in is equal to summation of current out. IY we took this direction, that is minus 10 milliampere, and others are going out. Let's put IZ is 0, and IW we just found it out, that is 108 milliampere, and then we are trying to solve for IO. If I bring the IO to this side, that's negative, so I mean if I bring 108 to this side, that's negative. IO is going to be negative 118 milliampere. So it just means that assumption is wrong. It's in the opposite direction. It goes this way. Okay, but if you put this way, you have to put a negative sign. That's the thing. And that's it for this video, guys. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel.